Jason Karl wants to grow tall corn. Not just tall like the stalks you typically see in fields. He wants to grow maize plants that stretch several stories in height. His strategy is to increase the number of segments on the stalks called internodes, which separate individual leaves, as well as to lengthen each internode. Although Karl started growing corn in his hometown in upstate New York, today his testing grounds are far from American soil, in Costa Rica. He builds custom greenhouses that accommodate these giant plants. The building's plastic filters the sun's light in a way that promotes faster growth. He also provides the plants with light after the sun sets, to keep them reaching skyward. The combination of the greenhouse and night light results in dramatic increases in height. But to really push the height boundaries, Karl decided to sprinkle in a genetic mutation. He started with a tropical strain called Chiapas 234 from southern Mexico that was naturally tall. He then crossed it with a temperate strain harboring a mutation called Leafy, which increases the number of internodes. Then he back-crossed the hybrid with the tropical strain to place the Leafy mutation in the tropical genetic background. Last year, he grew a record-setting 45-foot tall plant. This gangly specimen had more than 80 internodes. An unmodified Chiapas corn, grown under normal conditions, will have just 2 dozen. Karl says he's driven by scientific curiosity, as he recognizes that farmers are not interested in growing a corn so tall that it cannot support itself. But he wants to know how the numerous factors influencing corn height interact, and he's already working on his next project, adding more height-related mutations, such as one called delayed flowering.
All of these things have never come together for this perfect genetic and ecological storm of uncharted excessive maize plant height.
And while there may be no immediate application for his findings in the maize community, understanding more about the genes that govern plant height could one day inform the growing of other crop species that are used for biofuel or animal feed, where bigger is usually better.